Good morning to all. This is Kavita working as an assistant professor in the Department of Civil Engineering, KPR Institute of Engineering and Technology, Coimbatore. Now I am going to give a overview on seismic design. So here in this outline of this presentation is which includes introduction part of seismic and what are the effects for architectural features and what are the critical issues and the solutions given and overview of IS 1893 and shear valve overview. And here you can see this seismic. Here this earthquake is nothing. It is a series of vibration on the earth surface. Mainly it is due to this seismic waves. Here you can see the magnitude of this forces. Below this earth, here you have a soil here, and above the soil you have a structure like this. And in this ground you have a surface waves, and below this you have a body waves you have. So the main thing is we have there is a during release of accumulated strain energy, there may be a chance of sudden rupture within the earth. So this effect, how we can reduce it or eliminate it is we can give a proper structural design and detailing of the architectural viewpoint. So the structural system is directly related to the architectural configuration. So this architectural configuration is nothing. It depends upon the type of structural system what we are going to give and mass of the structure and what is the ratio of the building, whether it is a height and a depth ratio, how the length of the building it should be, how the breadth of the building it should be, everything we should consider. And here you can see the some seismic zones in India. Here we have a seismic zones of 4 seismic zones, 2, 3, 4, 5, and this main seismic zone 5 is all this Agartala, Aizawl, Gangtok, Guwahati, Impal, all this northeast and this above areas, everything it is falls under the category of seismic zone 5. And for seismic zone 4, some of the categories will be there: Delhi, Gurgaon, Patna, Simla and all, and Chennai, Kolkata, Lucknow, Mumbai, everything it falls on the category of seismic zone 3. So this is the seismic zones map in India. So when if it is a seismic zone 2, then your seismic intensity will be low only and your zone factor is 0.1, and these are the some of the important cities falls under the seismic zone 2. And this is a seismic zone 3 and the seismic intensity will be the moderate, the zone factor will be the 0.16, and these are the towns which falls under the category of here. And when it comes to zone 4, the effect will be severe and the zone factor will be 0.24, and when it comes to seismic zone 5, it is a very severe condition and the zone factor it comes under the category of 0.36. Here you can see the seismic zones 2, 3, 4, 5. In this percentage of geographical area, if you take the seismic zone 2, 41.4 percentage of this in this geological area in the seismic zone map of India, 41.4 percentage will falls under the category of zone 2. Altogether, that is zone 3, 4, 5, altogether it comes under the category of 58.6 percentage. And this is the seismic effect on the structure. This inertia force, if the more mass and if it is a higher inertia forces, your lighter buildings will sustain the earthquake shaking better also. But now this earthquake also we have to consider all the 3 directions. That is factor of safety, we have taken 1.5 times of dead load plus live load. It will resist both vertical shaking, but horizontal shaking will be the different. That is a critical. So all these vertical elements such as your walls, columns are the critical elements. It will transfer the inertia force to the ground. So these are the some of the various codes for the earthquake resistant design. IS 1893 criteria for earthquake resistant design of structures, IS 4326, IS 13827, IS 13828 for low strength masonry building, IS 13920. How we are using for IS 456 The detailing code will be SP34, that is for normal detailing. When you are going for seismic design, your seismic earthquake resistant design is ISO 1893 and detailing code is IS 13920/1993. And for repair and seismic strengthening, we have to follow the code of IS 13935/1993. And these are the some of the effective architectural features. So your building behavior depends mainly, this earthquake depends on the configuration. Suppose if your building is too tall, then there may be the movement of floor is high. If your building is so short and long, then the damage will be more. If you have a larger plan, this is a too long, then the damage will be more. If it is a too tall also, this movement of the floor is very high, and if it is too large in plan also, it will attract more seismic forces. So always when you are preferring your layout, you have to plan a simple plan geometry. So always you have to prepare a plan of building with a re-entrant corners like U, V. Suppose if you have a U, V, T or different shapes, then your stress concentration and this torsion will be very more. So better to avoid these type of configuration. Always simple rectangular type, it is a rectangular or square will be a simple plan, and it is very good also. So these are the some of the architectural features. Sometimes what we have to do is, if we have a plan like this, then you have to separate it. What is the solution for all this H type of structures, for plus, for pa, L, T, and for this hollow sections and all? So in this case, what you have to do is, you have to provide a separation joint like using splice. So you have to provide a joint like here you have to provide a separation joint, and then this building it will act separately, and this building it will act separately. Otherwise what you have to do is, either you have to strengthen this part, either this part it should be a stiffer element. You have to provide any shear wall like this, then that will be no need of torsion will occur. So this is the vertical layout. So these are the some setbacks we have to consider. Suppose if you have a plan like this, and if your building is like this, these are the some of the plans. So suppose earthquake forces in all the floors, it should be brought down along the height to be the ground in the shortest path without any deviation and discontinuity. If you have a discontinuity is there, then the load transfer will be a problem. So in that case, the seismic force will be transferred from the top to the ground. It should distribute the load properly. Accordingly, you have to give a architectural feature for that. Then vertical setback, sudden jump. So suppose if you have a intermediate, if you have a transfer girder or sudden jump it is there, then there may be a chance of earthquake forces. And if you are giving a like a open story, then it will be critical for that. Then suppose sometimes unequal height of the column, then there may be a chance of twisting and damage for this short column effect. And for this floating column also, that in seismic zone, that floating column will be a very critical, because the load transfer will be it is discontinuous. So better to avoid the floating column also. So this is the pounding element. Here if you see, here one building is there, here one building is there. So if the two buildings, if it is close to each other, then there may be a chance of more collision will be there. So we have to give a proper separation joint. So for this separation joint, there will be a formula for this. So here if you see here, if the building is here, if you see 1 2 3 4 floors, and here some 3 floors, but this floor height will be, this floor is terminated at the mid of this floor. For this, then the calculation, the gap calculation will be R into delta 1 plus delta 2. R is nothing, it is a response reduction factor into, this is your displacement at this floor and this displacement at this floor. You have to add and multiply with the response reduction factor and give a gap like this. And suppose if it is in the same floor, in that case you can consider R by 2 into delta 1 plus delta 2. Thank you.